The entire topsoil, the fertile part of the soil, is missing from a third of the U.S. Corn Belt. This data all sort of puts into perspective how imperative it is that we figure out a different way to farm that does not degrade the fertility of the land and that can better support not only feeding the world, but as we'll see, better support human nutrition with more minerals and more phytochemicals in our food. But let's look briefly to wrap up this discussion of past societies about the problems of net soil loss in the past. Net soil loss of roughly 1 millimeter a year, and that's about the pace that's a conservative estimate of the pace I could argue for, given the data that I've just showed you. At that pace, it would take about 500 to 1,000 years to erode through a 0.5 meter to 1 meter thick, so 1.5 foot to roughly 3 foot thick soil. That's typical of most hillsides around the world. And it turns out that that time scale, 1,000 years plus or minus, is approximately the lifespan of most major civilizations outside of major river floodplains. That was another aha moment I had in writing Dirt. That the time frame that it would take for conventional agriculture in terms of conventionally tilled fields to erode off the topsoil is kind of similar to how long most agricultural societies have lasted. But I also hope you're sitting there thinking, well, what about the Nile in Egypt? It's been farmed for thousands of years. Or the Tigris and Euphrates in the Middle East, the Indus and the Brahmaputra in India, or the big rivers of lowland China. These are all places where we know that agriculture has been practiced for thousands of years that still support large populations. So what is it about those places that seem to be perhaps a little different? And it's hidden right there in their physical geography, because all those places I just mentioned are big river floodplains. And what happens on floodplains? Well, they flood. And what comes along with the water? Well, it's not just water, but also silt, clay, sand, mineral particles. Nature can refresh and rebuild the fertility of tilled land on flat floodplains because they're fairly flat, so erosion is slow, and they're refreshed by flooding if they're allowed to flood and not diked off from their annual floods. And this is how societies were able to maintain agriculture over the long run in those parts of the world where we know of long-term agricultural civilizations. So they're kind of the exceptions that help to prove the rule that once farming gets out of the valley bottoms and up onto the hillsides that are vulnerable to erosion by water and rain, and where soil rebuilding takes place slowly under natural conditions, the clock literally starts ticking. And there's another aspect to soil degradation beside just loss of the soil itself, and that's loss of soil organic matter. This slide shows you two soils from adjacent fields, literally developed on the same geology, under the same climate, right across the fence from one another in North Carolina. So in that gray noodle that I was showing you earlier in terms of the magnitude of colonial soil loss, the loss of soil organic matter is also a big deal there. This is from the conventionally worked field over there on the right. It looks like sort of khaki California beach sand is kind of what it looks like to me. And there's a reason for that. It is beach sand. It's Miocene age, 10 million year old beach sand. So it's an old beach that's now well inland. That has hardly any organic matter, hardly any, there's hardly any life in the soil when we were digging this up for the comparison. The soil that's right across the fence line, it has more of a dark chocolate cake kind of a color. The difference, of course, is carbon. And soil organic matter is roughly 40% carbon, and carbon turns out to be the key currency that drives the underground economy that helps keep land fertile, that I'll get to and that Anne will be talking about a little bit more. But the key point here is that the second element of soil degradation and the decline of soil health is turning rich, dark, carbon-rich soil like the stuff on the left into soil like that on the right. And we've done that on agricultural fields all around the world. The most recent estimate of what the extent of the loss of soil organic matter from the North American soils is published in the journal Sustainability back in 2015, where the authors concluded that the soil organic matter content, and you can also read the soil carbon content, of many soils in North America is only about 50% of the level at the time when they were converted from forests or prairies to farmlands. In other words, we've lost about half of the soil organic matter in our farm soils, and that's equivalent to essentially draining the natural batteries of our soils by about 50% over just a couple hundred years. This presents a major problem for thinking about how to feed the world going forward, particularly as we look towards an agriculture in a post-oil world in which the reliance on synthetic nitrogen fertilizers is going to become much more problematic. So how did we get there today with modern farming practices that have resulted in widespread soil erosion off of whole regions of our country, and the degradation of soil organic matter, not only around the US, but globally off of many agricultural fields, taking it down by roughly half? Well, there's really two factors that are the primary things we can point to. Heavy routine tillage is essentially the first piece of it. We basically have been plowing too much. And when we plow, it basically aerates the soil, it exposes it to oxygen, so organic matter will oxidize, it stimulates bacteria in the soil to break down that organic matter, and we're not building then up organic matter. And also the overuse of synthetic nitrogen fertilizers is the second piece in terms of degrading soil organic matter, because again, that can overstimulate the bacteria in the soil that can break down soil organic matter and accelerate its loss from soil profiles. So the two key backbone practices of modern conventional agriculture, routine heavy tillage and the over-application of synthetic nitrogen fertilizers, have both contributed to degrading the fertility of land and the degrading soil organic matter. Have helped to maintain harvests, but not to maintain the native fertility of the land, thereby setting up problems in the future. So the question that I was left with after writing Dirt was actually kind of a big one. Can we reverse the historical pattern of soil erosion and soil degradation? And if so, how could we do it, and how fast could it occur? And this is where we transition to the sort of the good news part of the talk, because I've come around to being a bit of an optimist in thinking that we can not only restore the fertility of the world's agricultural lands that have been degraded, but we could do so remarkably fast with techniques that we already have, we already know, and that are soundly rooted in the science of soil ecology and the relationship of soil health to plant health. So I'm going to move into the second part of the talk here. We've looked at how farming practices can affect soil health. Now let's turn to looking at how soil health influences and translates into plant health. And that's a story that Anne and I started working on when we wrote The Hidden Half of Nature a few years back, our first co-authored book that set the stage for What Your Food Ate. And what it did for us is it helped provide insights into what kind of science we could use to help solve the problems that were unearthed, if you'll pardon the pun, in researching the Dirt book. So what are those kind of insights? Well, they flowed a lot from our garden. Anne is a biologist. She's a major league gardener. I like to think of her as a plant whisperer. She can bring plants back from the edge of death, but she also brought our soil back to life in our yard. When we bought a house in North Seattle, where we live back in the late 1990s, it came with soil like this khaki stuff over there on the left, a lot like that degraded North Carolina tobacco plantation. But over the course of roughly a decade of intensive compost and mulching and regenerative gardening, Anne turned this kind of a soil, the khaki soil, into this rich black earth shown there on the right. Took it from less than 2% organic matter up to pushing 10% organic matter, and the explosion of life that happened above ground in the garden was a great joy and benefit to both Anne and I. But that this could happen so fast, that we could rebuild the health and fertility of the soil in years, not decades or centuries or millennia, but in years, really put an exclamation point on the idea that we could rebuild soil fertility remarkably fast in ways that could transform agriculture and also, as it turns out, human nutrition, which we'll get to in What Your Food Ate. Who are the key players and actors? Well, what we learned in researching the why behind how it was that our soil in our yard was restored so fast really brought up the importance and power of the soil food web. And the soil food web is something that is basically shorthand for all the life in the soil, the organisms that are consuming each other and consuming the compost and mulch that we were layering on the soil in our yard to help build soil fertility, and all the bacteria and fungi and mycorrhizal, the mycorrhizal fungi in the soil that were consuming and breaking down that organic matter were basically repurposing that organic matter and the elements that were contained in it back into forms that could be taken up by plants to support their growth. And it turns out that the life in the soil that also is supporting is a great engine of getting things like mineral elements out of the soil and into our crops. Why? Because fungi like saprophytic fungi, or fungi that feast on dead things, are supported by both organic matter and and indirectly by plants in ways that Anne will be talking more about. But this illustrates just a fungal hyphae going out through the soil that latches on to mineral elements, and those fungi can basically, they're specialized at removing mineral elements from the soil, things like zinc, things like iron, and then they'll bring those back to plants, and they'll trade them to plants in exchange for some of the material for the organic matter that plants can produce and that plants can exude out of their roots in ways that Anne will explain in more detail. But what this means is that fungi, life in the soil, in a healthy, fertile, life-filled soil, the life in the soil can actually serve as root extensions for plants that help them acquire things like mineral micronutrients that the plants may not have access to in the immediate vicinity of their roots. And what are those things like? Well, they're things like iron, things like zinc, things like selenium, elements that we don't need a lot of to support our own health, and that plants don't need a lot of, but that we need that little bit an awful lot. That's what they're called, micronutrients. We need them in small amounts, but they serve disproportionately huge roles in both promoting the health and defense of plants, and also in supporting our immune system and in supporting the health of people. And it turns out that life in the soil are one of the key elements through which minerals get into our food. And the adoption of modern farming practices that have greatly changed the communities of life in the soil, that have disrupted the microbial miners and truckers that help to get mineral elements into our food, have played a role in the historically documented declines of mineral elements in food. For example, David Thomas back in 2003 wrote a paper that was looking at how mineral elements had decreased in fruits and vegetables over the course since the Second World War, essentially, and he found that copper decreased by 3/4, calcium decreased by just under half, iron decreased by just over 1/4, magnesium decreased by about 1/4, and potassium had decreased by about 1/8 or so. In other words, across the board, there's been some fairly large decreases in minerals, particularly in things like micronutrients like copper. And the hypothesis usually put forward to explain that, is that as we started to breed crops to be very productive in very nitrogen-rich environments, overly fertilized fields in modern agriculture, that we selected for plants that in those higher yields, the plants would be making more biomass, and so the things like copper and iron that they took up through their roots from the soil would be spread through a greater amount of, say, wheat kernels in the case of a wheat crop, and therefore in each bite of wheat you'd be getting, say, half as much or 1/4 as much of the minerals that we're looking at. So, but we think, Anne and I think, and have hypothesized and document the science in the series of books, that the degradation of soil organic matter and loss of soil life has contributed to the decline in mineral density in foods, in part because there are experiments that have shown that if you inoculate plants with particular microbes, and that you can enhance the uptake of things like phosphorus or iron or zinc, and that if you eliminate those or degrade those microbes and those connections, particularly the fungal connections, it turns out, it can have a big impact on mineral uptake by plants. This shows you data from some experiments that were done in Japan, where scientists took onion plants and they inoculated them with arbuscular mycorrhizal fungi, and they had a control, and they inoculated with 2 different kinds of fungi. And look over here on the right, in the green stuff, the phosphorus uptake by plants at different levels of mycorrhizal colonization. So the control that had no mycorrhizal fungi was taking up about 25 picograms of phosphorus per plant. If you look at the inoculated ones, they were taking up, that were well inoculated, they're taking up almost 10 times as much phosphorus. Now, phosphorus is something that modern conventional agriculture tends to apply in great amounts to our fields. But mycorrhizal fungi provide an agent for actually getting it out of the soil particles and getting it into plants, suggesting that there's alternative ways to fertilize crops that may not require as much nitrogen as we add if we basically had the right life in the soil, the right bacterial and fungal communities to actually unlock the potential of those elements in the soil and get those elements into our foods. And so that's a little bit on the connections in terms of soil life and what it can do to what's getting into our food. Growing a Revolution was the book that we wrote after writing The Hidden Half of Nature, when we realized that it's sort of one thing to bring your soil back to life in an urban lot in Seattle, where you've got a lot of coffee shops around, and the Seattle Zoo's just down the street with a supply of well-composted herbivore manure they like to give away on an annual basis because they haven't got a lot of it they need to get rid of. We was left asking the question of, well, could we bring soil back to life relatively fast on full-scale operational farms that were productive and capable of, at a scale, capable of feeding the world? That led to writing Growing Revolution, where I visited farmers around the world who had done to their farms what Anne had done to our lot. It's essentially the how-to story of how to basically move from an era of conventional agricultural chemistry or conventional agriculture that emphasizes chemistry into an era of regenerative agriculture that really emphasizes cultivating life in the soil to turn degraded lands back into verdant fields. How does this work? Well, the general principles of regenerative agriculture are ones that I found in visiting farms in equatorial Africa, Costa Rica, across North America, involved a combination of three key practices plus a potential fourth. And those three practices that worked on farms, subsistence farms up to really large, conventionally mechanized farms in North America, were to minimize the chemical and physical disturbance of the soil, which means not plowing, so going to no-till farming, but also going to minimal or no chemical use. So going to either organic no-till farming or going to no-till farming that used a bare minimum of chemicals, or to organic farming that used no chemicals but used a bare minimum of tillage. Those kinds of combinations, trying to minimize the disturbance of the soil, and always keeping the soil covered. That means with a living crop, a cover crop. So always keeping living roots growing in the ground for reasons that will become very apparent in Anne's half of this talk. And also diversifying crop rotations. So minimizing disturbance, that's providing a stable home for soil life, keeping cover crops growing. That helps to provide organic matter when those cover crops are knocked down and mulched into the soil. And maintaining a diverse crop rotations, that's about having a diverse community of life in the soil, so that there's multiple positions that soil life can play to partner with crops in ways that Anne will talk more about. And the fourth element of regenerative agriculture that I view as a potential accelerant for soil building is reintegrating animal husbandry into cropping operations, so that their manure can actually help stimulate both the soil biology and to help build soil organic matter. Now, there's good and bad ways to do that. If you overgraze the landscape, integrating animals with farming can destroy the land, but there are regenerative methods and ways to do that that can help to build soil fertility and to help increase the productivity of the land. Now, the principles that are involved are fairly generalizable. They translate to other settings, but the specific practices need to be tailored to the specific setting of the landscape. So the farmers I visited, say, in Costa Rica, were not using the same practices as farmers that I visited in North America or in Central Africa. But the general principles, that minimal disturbance, the cover crops, and the diversity, and then the potential to accelerate with regenerative grazing practices, translated to settings around the world and actually paralleled what Anne was doing in our yard in terms of her regenerative gardening. What kind of results can it produce? Well, it can turn soil like this clay on the right into soil like the one on the left. These are both the Cardington clay soil. It's the soil from David Brandt's farm, from his family farm in Carroll, Ohio, where they grow wheat, corn, and soybeans for the North American commodity crop markets. But they also grow diverse mixtures of cover crops. They'll grow up to, I think they're up to probably 15 or 20 different kinds of cover crops, even in a single mix in the field at present. So they always keep something growing. And this is the kind of soil David started with back in 1971. This happens to actually come from his neighbor's farm, which he just bought recently for reasons that will become apparent in a moment. And this is the soil that David has built on his farm. He's turned that khaki clay into a rich chocolate cake that's permeated with holes, full of life, very productive. He's been able to greatly reduce, and I think at this point pretty much eliminate, his reliance on nitrogen fertilizers and chemical fertilizers and pesticides in a way that has really helped his bottom line. So this is David here, shown modeling one of his tillage radishes out in one of his fields by his neighbor's yellow soybeans, and he's got a mix of crops growing there in that field. But he was kind enough to walk me through the economics of his operation and his conventional neighbors, where his conventional neighbors are doing full tillage. They're plowing a lot. They're using 200 pounds of nitrogen per acre, 2.5 quarts of Roundup, that's glyphosate per acre. And that's costing them $500 an acre in sunk costs. And at the year that that I visited his farm, they were county average yield is about 100 bushels an acre at $4 a bushel. What they're getting that year, that means his neighbors were losing $100 for every acre of corn they planted. The more they worked, the more money they lost. That is the key. That's the Achilles heel of modern conventional agriculture, where the input costs have gotten so high and the commodity prices have gotten so low that it's actually very difficult to turn a profit as a farmer. What David Brandt has done is he's gone no-till for 44 years. He then started to integrate cover crops and a diversity of cover crops in his operation. And now he does no tillage. He only uses, the year I visited, a little bit of nitrogen, a little bit of Roundup. So he's not an organic farmer. I teased him that he was organic-ish because he was moving so close to being an organic farmer that it'd be very simple for him to go that last mile. What he was doing was costing him $320 an acre. He harvested about 80% more than his conventional neighbors, and at that pace he was making $400 an acre when his neighbors were losing $100 an acre. This is part of what turned me into an optimist, to think that regenerative agricultural practices, the combinations of practices that he was using, could actually could catch on among conventional farmers across North America and move them much closer to the world of organic agriculture. These kind of practices also worked on subsistence farms in Africa. This gentleman here is Kofi Boa. He runs the no-till center in Kumasi, Ghana. He's been teaching villagers in his region how to move from their traditional slash and burn or Swidden style of agriculture to using a no-till method with cover crops. They have small farms that are worked by hand, but what this has done is it allowed them to basically shut off erosion. When you basically slash and burn, it actually is fairly erosive after the burning. And so notice what happened to the amount of soil erosion on the fields in this area. They went from 1,800 kilograms per hectare per year, which is kind of an abstract number, I realize, but just notice it dropped from 1,700 down to 77. It almost shut off erosion. What happened to their crop yields? Their traditional yields of 1.5 tons per hectare of corn increased to 4.5 tons. They tripled. And the yields of cowpeas basically doubled. Doubling and tripling of crop yields is better than the Green Revolution did. And this was done on fields using no agrochemicals, using no tillage, no agrochemicals. It was a way of thinking about the soil and rebuilding soil health through the adoption of those principles of minimal disturbance, cover crops, and diversity. These folks got diversity into their fields by growing 8 or so different crops in the same field at the same time with the polyculture, low crop, ground hugging crops, and tree crops. But the point is that they revolutionized their agriculture and rebuilt and revolutionized their soil. This next soil that I'll show you is from the Singing Frogs farm, the Paul and Elizabeth Kaiser's farm in Sebastopol, California. And the soil on the left is from a neighboring field, literally across the fence from their farm. And it's what they started with in terms of soil quality. They then spent about 10 years at this point rebuilding soil health through essentially an organic no-till vegetable farm. They're not certified organic, but they're not using any chemicals. And notice the difference in the soil. It started off the same just 10 years ago. The pace of soil building is remarkable in this case. And they're not alone. One more example. This is Gabe Brown's farm in Bismarck, North Dakota. In his right hand, he's holding up the soil from his market garden where he applied those regenerative agricultural principles. The soil in his left hand is his neighbor's soil. You'll notice the color difference. Again, that's carbon. It's basically carbon taken out of the atmosphere through photosynthesis and put into the ground through agricultural practices. It's a way to actually help mitigate the greenhouse gases that are causing climate trouble. And the potential for that is actually huge globally. What happened at Brown's Ranch is that he started off with 3 inches of topsoil back in the early 1990s when he first went to no-till. He had about 2% organic matter. He then diversified his cash crops, diversified his integrated cover crops in the late 90s, went to multi-species cover crops in the late 2000s, it reintegrated livestock in 2010. By just a few years ago, he turned that 3 inches of topsoil into 14 inches, more than tripled it. And his organic matter was up to 6%. He more than tripled it. those are huge changes, and in a time frame that is geologically instantaneous. To be able to completely restore the fertility of your land so that it is basically functionally equivalent to a native prairie, and do it in less than 20 years, is remarkable. And yet he's done it, and other people have done it as well. And they've done it profitably, which is what makes me an optimist on this issue. This is a slide from a paper by Claire Lacan and Jonathan Lundgren that was published back in 2018, the year after Growing Revolution came out. And what they did is they compared the economics of regenerative and conventional farms in the Corn Belt across the American Midwest. And what this shows you is the revenue and cost per hectare for the averages across those farms. So the way you read the graph is the bar at the top, that's how much they harvested, that's what they got for their harvest per hectare. They spent all the colored stuff on corn seeds and crop insurance and herbicides and fertilizers and so on. And the profit is the bar on the bottom left over. The regenerative farms are shown on the right. You'll notice that they harvested more. They got a better income off their fields because their yields went up once they restored fertility to their land. And they spent less doing it. These were not organic farmers. They were conventional farmers, but they were weaning themselves off of conventional inputs, and they were left with a much healthier profit in the end. That's what really started turning me into an optimist on this issue of what could of whether or not regenerative practices could be adopted. Another benefit of rebuilding the health and fertility of soils is that healthy soils have a higher water holding capacity. For every 1% increase in organic matter, you can hold up to 20,000 gallons of water per acre, water that will sink into the ground to be available for growing crops. Photosynthesis only works if you have sunlight and water. So water is the big vulnerability for agriculture in many regions, and healthy soils have a better ability to not only absorb that water, but to hold on to it and make it available to crops. So there's lots of benefits of farming with healthy, fertile soils. I put at the top of the list higher farmer profits. Comparable yields after conversion are a big part of the reason for that. The other half of it is that farmers can use less fertilizer, pesticide, and fossil fuel while harvesting those comparable or greater harvests. And that is a recipe for a healthier profit. But it also means that there's more carbon in the soil, and that's carbon taken out of the atmosphere and put into the ground, taken from a place where it's a problem to put it in a place where it's a net benefit, not only to the farmer, but also to the health of the land, and ultimately, as we'll see, to the nutritional content of the foods that we harvest off these lands. And it also means that there's less off-site pollution. If we're using less soluble nitrogen and phosphorus as fertilizers, then less of it's getting into rivers, streams, groundwater, the Gulf of Mexico, all the places that the overuse of fertilizers have contributed to environmental degradation. Now, the one thing I haven't shared with you yet is, well, what does this mean for actually the nutrient density of our foods that were grown? These regenerative soil building practices. So Anne and I and Ray Archuleta, Paul Brown, and Jasmine Jordan did a brief study when we were writing What Your Food Ate to look at the effects of what do these regenerative farming practices mean for the health of the land and also what's in our food. So we took 10 paired adjacent farms, both a conventional one and a regenerative one, across the U.S., shown here on this map. So from California all the way over to Connecticut. We just tried to find farms where the farmers had been doing regenerative agriculture for between 5 and 10 years, involving all three of the practices: the minimal disturbance, the cover crops, and the diversity. And then we sampled their soils, and we had them grow the same crops, literally across the fence line, and then compare the nutrient density of those crops. So what do we find in the soils? That's the first, the box and whiskers plots down here in the lower left-hand corner of the screen. The percent soil organic matter on the regenerative farms was about, on average, twice what it was in the conventional farms. In other words, it had basically, within a couple decades, well, actually within about a decade or so, although some of them have been doing no-till for longer, within a short period of time, they had restored their soil to comparable to what the native soil was, reversed that 50% loss of soil organic matter that I told you was so common on agricultural lands around the world earlier. So they'd reverse that in their topsoil, and their soil health scores had tripled. So the amount of life in the soil and its activity had really gone up. So they had life-filled, fertile soils, that had been restored. What did this do to what's in their foods? Well, it increased the phytochemical content by 15 to 20%. What are phytochemicals? Phyto is plant, chemical is a chemical, plant-made chemicals. Things like carotenoids in carrots, the stuff that make them orange. It's a good UV protector. Phenolics, phytosterols, things that are antioxidants, anti-inflammatories when they get into our bodies and that serve other purposes in plants that Anne will talk about. Mineral micronutrients were up 15 to 30% for certain ones. And the soil health scores, as I mentioned, had gone up, factors of 30% to about 2.5 times, depending on which paired farm we were looking at. So in other words, there's evidence that these regenerative farming practices are not only good for the land, but they're also enhance the nutritional quality of the foods that we harvest off the land. So finally, in the last couple minutes that I have, I'm going to basically share sort of my vision of where we are, I think, in the world of agriculture. We've gone through a series of 4 agricultural revolutions. We're poised now for a 5th one, and that is the first revolution was the idea of cultivation and tillage in the first place. This is the Greek goddess of cereal, Ceres, just for illustration. But agriculture itself was a radical idea and a revolution in human lifestyles. The second agricultural revolution was when we started thinking about soil husbandry, adding legumes to crop rotations. The idea of cover crops and crop rotations are not new ideas. These are very old and traditional ideas that were brought in, I would argue, in the second agricultural revolution, where people started doing things to maintain the fertility of the land, but that didn't always sustain it because of the over-reliance on tillage. And that's where we have an opportunity today to combine no-till practices with the ancient wisdom of things like cover crops and crop rotations. And it's just my favorite quote from Leonardo da Vinci about we know more about the movement of celestial bodies than about the soil underfoot. How many things in science can you say that about? That from a quote from 500 years ago is as true today as it was then. Many of the connections that we write about in What Your Food Ate, that Anne will be getting to in a moment, are basically discoveries in the last couple decades that have revolutionized our way of looking at agriculture. But the third agricultural revolution was what happened in the 19th and early 20th centuries in terms of mechanization and industrialization. No big mysteries there. I like to think of the fourth agricultural revolution as the green revolution and biotechnology rolled into one. I won't editorialize about either of those, but let me basically say instead that I think we are poised for what I hope will be a 5th agricultural revolution, and that is one that's focused on building soil health, on the kind of regenerative farming practices that we've been writing about and talking about so far in this talk that can rebuild the health and fertility of land as a consequence of intensive farming, and thereby not only improve the environment, but pull off the daunting challenge of feeding the world going forward, but also, as Anne will be emphasizing,